Okay, back with lecture 5 from chapter 2. This is the second lecture on trade. Start out by reviewing. We're looking at two countries, Lilliput and Fredonia. And so over here I gave you some production numbers, and this is how a question on the test would be. One worker in Lilliput can produce 2 computers or 10 tables. And then we said that one worker in Fredonia can produce 30 computers or 15 tables. And the or again is what means the cost. So it's one or the other. It's either in Lilliput, it's either 2 computers or 10 tables, or 10 tables or 2 computers, not both. And in Fredonia, it's either 30 computers or 15 tables, or 15 tables or 30 computers. It can't be both. And so the first thing I would ask you is about absolute advantage. And absolute advantage, again, means you can produce more with the same resource. And so who can produce more with one worker? In terms of computers, well, the answer is Fredonia. We said last time that Fredonia has the absolute advantage because Fredonia can produce in one day 28 more computers than one worker in Lilliput. And then the other question on absolute advantage for tables, again, the answer is Fredonia because one worker in Fredonia can produce in one day 5 more tables, 15 versus 10, than one worker in Lilliput. And so it is possible for one nation or one trading partner to have the absolute advantage in both products. But again, absolute advantage has nothing to do with trade. And so the next thing we did was figure out comparative advantage, and to get the comparative advantage we have to go to opportunity cost. Because comparative advantage is who can produce the item at a lower opportunity cost. And so the cost is that or right there. And so let's find the cost of making one computer. We're going to go to one computer because up here I have 2 computers and I have 30 computers. It's not a fair comparison. So get it down to 1, and that's a fair comparison. So we took the numbers up here and brought them down here. So I don't know the cost of one computer in Lilliput, but I do know the cost of 2. We just said it's 10 tables. So if 2 computers have the cost equal to 10 tables, then we can reduce the 2 down to 1 by simply dividing 2 by 2 itself, and that's 1. We've got to divide 10 by 2 to keep the equality sign intact, and that gives us 1 computer has a cost equal to 5 tables. Do the same thing to Fredonia. We know the cost of 30 computers. It says at the top there it's 15 tables. I want to get it down to 1 so I can compare with Lilliput. And so we take 30 divided by 30 gets it down to 1. We have to divide the 15 by 30 as well, and that gets it down to 1/2. So every time they make a computer in Fredonia, it's going to cost 1/2 of a table. So now we know who has the comparative advantage in computers, and that is going to be Fredonia because they can make a computer at a much lower cost than they can in Lilliput. Do the same thing for tables. We know the cost of 10 tables was 2 computers. We want to get down to 1 so we can compare with Fredonia. So I divide 10 by 10 to get my 1 table. I divide 2 by the same 10 I get 1/5. So 1 table in Lilliput costs 1/5 or 20% of a computer. Do the same thing over here in tables for Fredonia. We know the cost of 15 tables is 30 computers. I want to get it down to 1 so I can compare with Lilliput. 15, get it down to 1, divide by 15. 30 divided by 15 gives us 2. So 1 table costs in Fredonia 2 computers. So now the comparative advantage can answer the question right here. In terms of computers, Fredonia does because the cost of producing 1 computer in Fredonia costs 1/2 a table, which is a lot less than 10 tables given up in Lilliput in order to produce the same 1 computer. And down here, comparative advantage for tables goes to Lilliput because the cost of producing 1 table in Lilliput costs 0.2 or 20% of a computer, which is a lot less than the 2 computers given up in Fredonia. Now, even though it's possible for someone to have the absolute advantage in the production of both goods, it is mathematically impossible to have the comparative advantage. There might be a case where the cost is the same, in which case no one has any comparative advantage. But if one trading partner has the comparative advantage in one item, then it's automatic that the other trading partner has the comparative advantage in the other product. So even though Fredonia might be very good at making tables and computers, Fredonia again has the absolute advantage in tables, but they really do a much better job at computers. So even though you can do well in both, or you can do something better in 2 items, doesn't mean you want to produce those 2 items. Because again, by producing tables, you have a really high cost, which is 2 computers in Fredonia. So next step is to maybe look at the benefits of trade. And so what I'm going to do is I'm going to have a before and after example. And I have to set this up. And so what I'm going to do is I'm going to make an assumption that each nation has 1,000 workers in each has 1,000 workers to use. And then let's divide those 1,000 workers over different production combinations. Come up with the production possibilities for Lilliput and one for Fredonia. So here, if we're going to have all of our workers making tables, remember each worker can make 10 tables. That's 1,000 workers times 10 tables, that's 10,000. If we want to produce some computers, then we have to give up some tables. We know that in Lilliput, the cost of making each computer is 5 tables. And so if they're going to produce 400 computers, they have to give up 5 times that amount in tables, and that's why it goes down by 2,000. So every time they produce 400 more computers, they're going to fall by 2,000 in terms of tables. The other extreme is all 1,000 workers making computers. Remember, they can make 2 computers per worker, so 1,000 times 2 is 2,000, and that takes the entire workforce. Likewise, going this way, if they're going to be producing computers and they want to start making some tables, they have to have a cost. And again, the cost of producing each table the cost of producing each table is 20% of a computer, and so 2,000 tables, you would have a cost of 20%, 0.2 of each one. You times 2,000 by 0.2, you would get the 400 decrease in computers. Over here, if we're going to be producing tables going in this direction, if we have all of our workers making computers, remember each worker can make 30 computers. That's 1,000 workers, that's 30,000 computers. If they're going to be making some tables, remember the cost of each table is 2 computers, really high. And so if they make 3,000 tables, they have to give up 6,000 computers. 3,000 tables, 6,000 computers, and so on, until we get to the other extreme when all the workers are now making tables. So what we have here is constant cost. The cost is constant all the way up and down the frontier. Not increasing cost, so it's probably not, this is a simpler type of model. It's probably more realistic to have increasing costs, but that makes it more difficult to show the benefits of trade. And then we can plot these numbers down here. So this is 0, and so 10,000 zeros right there, and then they have 8,400. And so you can plot out all the points on each country's production possibilities frontier. And it's going to be linear because the costs are constant. Get a ruler out. Draw a line through those points. That is the production possibilities frontier for Lilliput. And do the same thing for Fredonia. Again, that's 0. And so again, it's going to be linear. The ruler out again. Draw a line there. And this maps out the production possibilities frontier for Fredonia. Now we can put them anywhere on this frontier. And so what I'm going to do is I'm going to pick a position on the frontier that I'm going to call self-sufficient. Which means I'm going to put them exactly in the middle. And so I'm going to put 500 workers in Lilliput making tables. And so each worker can make 10 tables. 500 workers making tables gives us 5,000 tables. And then we have 500 workers making computers. And that was 2 computers per worker. So 500 workers making 2 computers. 500 times 2 is 1,000. And so right smack in the middle, it's going to be right here. We have 1,000. And we have 5,000. And so that puts them right there. And that's halfway in the middle. So they have half the workers making computers, half the workers making tables. Do the same thing for Fredonia. 500 workers naked computers. That was 30 workers per computer. So 500 times 30 gives us 15,000 computers. Somewhere about there, right smack in the middle. And then they can make 15 tables per workers, and 500 workers times 15 is 7,500, which puts us about there. And again, that would be 7,500 tables, 15,000 computers, and so each nation is on their production possibilities frontier, right smack in the middle. Trying to be self-sufficient, split the workforce 50-50. Now what I'm going to do is I'm going to show what happens if they can specialize in their comparative advantage and then trade. Before I do that, I just want to show this number here because I want to compare that with what I do after they specialize. So what I did here is I combined the tables in both nations. So together they're making 12,500 tables, and together they're making 16,000 computers. Now I've already told you that if you have to produce more of one good, you must give up this. You must give up some of the other good, and that is true within a nation. But we're going to find out it is not true if you trade and specialize in trade, and that'll be the topic of the next lecture. And so we'll stop there.